Going back to our Argand diagram, find the modulus and the augment of a given complex number. We should be having a fair idea on the Argand diagram. So going back to our Argand diagram, we have the x-axis, we have the y-axis. Taking the general form of a complex number, a plus bi, which is equivalent to x plus yi. The real part a is on the x-axis and the imaginary part b is on the y-axis. So modulus simply means the distance of the corresponding point, that is a and b, from the origin, gives the modulus or the length, which is also called the radius. And from Pythagoras theorem, we know that to find the radius, so provided our complex number is called z, to find the modulus of z, which is represented as magnitude of z, it should be equal to square root of a squared plus b squared. This is the knowledge from Pythagoras theorem, of which if we are to find the hypotenuse, so we want this is r, or magnitude of z. So this is what we want, okay? And to find this line, which is the magnitude of z, is a squared plus b squared square root of the sum of these. So this is going to inscribe an angle theta. So the angle theta also is the augment. And from this, we know that to find the angle theta, we can use tan of theta equals our opposite. So taking the angle, the opposite side of the angle is b and the adjacent side is a. So b over a. To find the angle theta, we have to divide through by tan. We have tan inverse of b on a as theta. So to find the modulus, which is also called radius, this is the formula. And to find the angle or the augment, this is the formula. Let's take examples. To be z equals 2 minus 3i. So to find the modulus or the radius of this becomes modulus or radius of z equals root of 2 squared plus 3 squared, which becomes root of 4 plus 9, which gives root of 13. We have z to be equal to 3 plus 4i. To find the magnitude of z becomes square root of 3 squared plus 4 squared, which gives square root of 9 plus 16. Root of 25 is equal to 5. To be able to compute the augment of any complex number, you must know where the complex number lies in the Cartesian plane or on the Argand diagram. So taking our argand diagram, we have the x-axis to be the real part and we have the y-axis to be the imaginary part. So let's see these 4 examples. So taking the first example, the x-axis, that is the real part, is positive, and the imaginary part too is positive. So that means it lies in the first quadrant. It lies in the first quadrant. So the angle will be here. So our angle theta is simply tan of theta equals, so tan, that is opposite over adjacent. Therefore our theta equals tan inverse of B over A. Because this angle lies in the first quadrant, the value you get after computing, that is your answer. So that means in a situation where our real part is negative and our imaginary part is positive, that means it lies in the second quadrant. It lies in the second quadrant, and we always find the angle which is with respect to the x-axis. So that means this angle. So to find this angle, we have our negative A and we have our positive B. So we use the same idea. So our theta equals tan inverse of B on A. We can ignore the negative for now. So to find this two, after computing your angle, the whole of this place is 180. So if we want this angle, we have to subtract it from 180. Okay, so here it becomes 180 minus theta. The value of theta you get, you subtract it from 180. Let's take the third example. So when the real part is negative and the imaginary part too is negative, that means it lies in the third quadrant. We use the same formula to compute this angle. Our alpha equals tan inverse of B on A. Okay, but right now we want the angle from here, starting from the origin. Okay, so the whole of this place is 180. So we add it to this angle. We add it to this angle, and then we have our angle. So here too becomes 180 plus alpha. The last example is when A is positive and B is negative. That lies in the fourth quadrant. So in the fourth quadrant, our B is negative and our A is positive. So you want this angle. So to find this angle, we subtract it from the whole of this. Okay, we know that angle at a point is 360, so we subtract it from 360. Let's call this beta. To find the angle in the fourth quadrant is 360 minus beta. Okay, so let me give you the key note here. So the very key note that you should know anytime you are computing the argument of any complex number is to first of all know the quadrant that it lies. If it lies in the first quadrant, is the same angle you get. If it lies in the second quadrant, 180 minus the angle you get. When it lies in the third quadrant, 180 plus the angle you get. And when it lies in the fourth quadrant, 360 minus the angle you get. 360 minus the angle you get. So you should be having this in mind anytime you are computing for the argument of any complex number. Let's take this practical example. So our first example, we have 3 plus 3bi. We have our second example, minus 3 plus 3bi. We have our third example, negative 3 minus 3bi. And we have 3 minus 3bi. Compute or find the radius and so to find the radius and the argument, we first have to know, since they all have the same values, the magnitude of this is going to be the same. So to find the magnitude of z becomes square root of 3 squared plus 3 squared, which is square root of 18. That gives square root of 9 times square root of 2. Square root of 9 is 3 and square root of 2 is still square root of 2. So that gives 3 root of 2. Let's compute the angle. Taking the first one, 3 plus 3bi, our theta equals tan inverse of 3 over 3, which is 1. So tan inverse of 1 equals 45 degrees. Because let's go to our Argand diagram. So the first one lies in the first quadrant. It lies in the first quadrant. So the radius 3 root 2 with an angle of 45 degrees. Because it lies in the first quadrant, we need not to add or subtract any angle to it. Let's take the second one. 3 plus 3bi. We already know that the radius is 3 root 2. And the angle here, instead of adding the negative to your computation, we can ignore the negative, which is tan inverse of the negative will only help us to know the quadrant that our complex number lies. So tan inverse of 1 is still 45. Let's see where it lies on our Argand diagram. So on the Argand diagram, the real part is negative and the imaginary part is positive. So that means it will lie in the second quadrant. Three root 2 So here is 45. Here is 45. And to find this angle is 180 minus 45. 180 minus 45. That gives 135 degrees. Let's take the second example. In the third example, we can see that A is negative and B is also negative. So it lies in the third quadrant. So we have our magnitude, which is our radius, as 3 root of 2. And we have our angle to be 45 degrees. So we find the angle from here to the origin is 180 plus 45. That gives us, that's 225. In our last example, we can see that the B is negative and A is positive, so that lies in the fourth quadrant. B is negative, so we have our negative B and we have our positive A, which is 3 and 3. So over here is negative, so negative 3. Tan inverse of 3 on 3 gives 45 degrees. So to find the angle from here to the origin is 360 minus 45. That gives a value of 315 degrees. If you have any question, you can leave it in the comment section and we will attend to you. Thank you for watching. Don't forget to subscribe.